Okay, so in the last unit, we were talking a lot about linear functions. You don't have to write this down. I'll tell you when to start writing. We were talking about linear functions. We all know that when you graph a linear function, it makes a straight line, correct? Okay, it can go up from left to right, it can go down from left to right, it can be up and down, vertical or horizontal. But a linear function will always make a straight line. A linear function is always in the form y equals mx plus b. Now, one thing we don't really go into a lot is the fact that isn't that x always raised to the first power in a linear function? Have you ever seen a linear function with like y equals 3x squared plus 2? No, it wouldn't be a linear function. Okay, linear functions are always x to the first power. Well, today we're going to start talking about quadratic functions. Quadratic functions form a graph that's called a parabola. Okay, and it's not a line, it's a U-shaped graph. Okay, it's kind of in between a V and a U. Okay, and then their x is always squared. Okay, that's the main difference between a linear function and a quadratic function. With a linear function, the x is to the first power in the equation. With the equation of a quadratic function, the x will always be to the second power. Okay, so we're moving on to quadratic functions today. So go ahead and turn to the first page. Okay, today we're going to graph various functions and make conjectures based on the patterns we observed from the original function y equals x squared. Now, y equals x squared, they call it original function. It's also known as the parent function. Kind of like y equals x is the parent function to all linear functions. It's like the most basic linear function you can have. What's the slope of this? 1. Isn't there an understood 1 in the m place? And what's the y-intercept? 0, because there's nothing in the b place. So this is like the most basic linear function, right? That's known as a parent function. So that's a parent function for linear. This is the parent function for quadratic. Okay, so the first thing we're going to do is we're going to use this t-chart, this table of values, to sketch our parent graph of y equals x squared. Well, haven't they just given you a bunch of x values? And in that equation, y equals x squared, don't you have an x that you can plug in that number to? Well, what is negative 3 squared? Positive 9. Let's talk about y. When you type it in the calculator, you absolutely must put the negative 3 in parentheses. Because we all know negative 3 squared literally means negative 3 times negative 3, right? Doesn't everybody know that negative 3 squared is negative 3 times negative 3, and a negative times a negative is a positive? But let me show you what your calculator will try to do. If you just type in negative 3 and don't put it in parentheses and you square it, your calculator will spit out negative 9, which is wrong, because we all know that a negative 3 times a negative 3 is a positive 9. This is why your calculator is getting it wrong. Only the 3 is touching the 2, correct? So the calculator only understands to square the 3. It's not squaring the negative. So it's like 3 squared is 9, and then the negative just reattaches. If you put the negative 3 in parentheses, and then you square it, that lets your calculator know that we're not only squaring the 3, we're squaring the negative. And a negative times a negative is a positive, a 3 times a 3 is a 9. So do you see how important it is that you put any number in parentheses before you raise it to an exponent? Okay, so what is negative 2 squared going to end up being? Positive 4. What about negative 1 squared? 0 squared, 1 squared, 2 squared, and 3 squared. Okay, now we're going to plot those 7 ordered pairs to make our graph. So how do you plot the point negative 3, positive 9? Correct. Left 3, and then up 9. How do you plot the point negative 2, 4? Left 2, and then up 4. What about the point negative 1, positive 1? Okay, Okay, 0, 0. Okay, at the origin, and then 1, 1. 2, 4. Right 2 up 4. Get in the habit of saying right or left because over could be either way. And then 3, 9. Correct. So see how when you connect those, it makes, I know it's not perfect U, but it's also not a perfect V. Because think about it. A V is like two straight lines. This can't stay straight because to meet every one of those points, don't you have to curve it a little? And that curve is caused by the fact that as you go right 1 unit every time, aren't the Y values shooting up by more and more each time? So that's what causes that curve, because as you increase the X values, the Y's increase faster and faster. Okay, like if you start with 0, 0, when you went to 1, it just increased by 1. But then when you went to 2, it increased all the way to 4. When you went over 3, it increased all the way to 9. If you went over 4, it would go up all the way to 16. If you went to 5, it would go all the way up to... So see how as the X's are only increasing by 1s, the Y's are shooting up faster every time? That's what causes that slight curve, and that is known as a parabola. Okay? So any equation that has X to the second power is going to be a U-shaped graph. Now, they're not always going to start out at the origin like this one did. The reason that one started out the origin is because all it was X squared. There was nothing added to it, nothing in front of it, no negative. And that's what we're going to learn about today, though, what those things will do to it when you add stuff to the parent function. Okay, so this is what I want you to do first. Take your calculator, and just so we're not having to clear out stuff from earlier in the day, let's go ahead and clear our calculator. Second plus sign 7, 1, 2. Second plus sign 7, 1, 2. First thing you want to do to graph is hit Y equals. I'm hovering over it. See Y equals up there in the top left? Click it once. It'll take you to this screen. Once you're on that screen, we are ready to type in some equations. The first one we're going to type in is just the parent function, x squared. So let's talk about how to type in x squared. See right here, this button that says x, t, theta. It's like a fancy O. Hit it, and it'll pop up an x. To square that x, go over here to the left column, go down, see that button that says x squared? Hit it once, and it'll square it. Now when you hit graph, doesn't that graph look like the one we just did ourselves? Bless you. Okay, now let's type in the next one, x squared plus 3. So go to y equals, but leave that one in there because we're going to compare all of them to our original parent function. So go down to y2 and type in x squared plus 3. And now hit graph and see what that adding on the 3 did to the graph. What did it do to it? It raised it 3 units. Look, the blue one, the original one, that was just x squared plus 0, started at 0. This one that was x squared plus 3, didn't it move it up 3? And that's all it did. It did not make it smaller. Okay, and I'll prove to you why. But first, let's write that. So this one moved the vertex up 3 units. Okay, now everybody always looks at that, and I understand why you want to say it makes it smaller, because it does look a little skinnier. However, I'll try to explain it in 2 ways. Considering that we moved it up, aren't you seeing less of the graph? You're seeing less of the view? So like, think about if if I were able to cut, like think about it, we only see this much of it, right? From there to there. So if I only saw that much of the blue, and I covered up this, doesn't that now look about the same width as that red one up there? Do y'all understand that? Like if I don't know if it'll let me write, let me try. So the next time, I'm going to graph y equals x squared plus 7. So y equals, go down to y3, and type in x squared plus 7. Yeah, once you type it in, you can hit graph. It's a lot higher. Right, look. This one went up to 7 and started there, right? Its vertex is at 7. Now, yes, it looks skinnier, but remember, it's not really skinnier. It's just because we can only see the bottom of it. If we could only see the bottom of the blue, wouldn't it look just as skinny? Think about it. If you can only see from here down of the blue, wouldn't it look the same width as this black? Yes. The only reason it looks wider is because you can see how the lines are going out. We can't see the black lines going out right now, but we could if we, did like we did a while ago. Okay, so, hold on one second. What did the plus 7 do to the graph? Right, it moved it up 7 units. And then aren't both of these shifts from the origin? So out in parentheses, just write from origin, because it always moves it from 0, 0. So the conjecture says the parent of y, or the graph of y equals x squared plus a will cause the parent graph to, what does the plus cause it to do? Move up. And in this case, a units, because they didn't actually give you a number, they just said a. So whatever number's there, that's what it'll move up by. Okay, well hold on there. Save it for later. Okay, now let's try this one. So go back to your graphing calculator. The first one's y equals x squared again. So you can leave it, but go ahead and clear out your y2 and your y3. Okay, the first one, you just go down to it and hit clear. Okay, the y1 is x squared, which we already have in there. Y2 is now x squared minus 3. So x squared minus 3. Okay, hit graph and see what that minus 3 does to the parabola. It moved it down 3 units, which made it look a little wider, but is it any wider? No, we can just see more of it, which makes it appear wider, but it's not. So what do you think was going to happen when we type in x squared minus 7 for the third one? It's going to lower it down 7 units from the origin. That's at negative 7. Okay? So, moving it, or x squared minus 3 moved down 3 units. And then x squared minus 7 moved down 7 units. Yes, and then remember, all of these moves were from the origin. Like it moved down 3 units from 0, 0. And then the second one moved down 7 units from 0, 0. So the graph of y equals x squared minus a will cause the parent graph to move down a units. And a will be a number. Just right now it's a letter because it's a rule. Okay, so let me recap what we've learned so far. We saw that when you have just y equals x squared, and all of a sudden at the end you add on a number, adding means it moves it up, and it moves up by that number. Okay? We also learned that when you have x squared and you minus a number from it, it moves it down by that number. Does everybody get it? Okay, now let's look what happens right here when you have parentheses around the x and the number. So go ahead and type in the y1 and the y2. Okay, y1 is just still x squared, your parent function for a quadratic. And y2 is parenthesis x plus 3 squared. Now you've got to make sure that the x plus 3 is in parentheses and the squared is on the outside. Yes, so the parentheses will make a big difference. Okay, so now that you have it typed in, hit graph, and what happens? It went left. So it kind of does the opposite of what you would think, because normally our common sense would tell us plus means right, correct? But with horizontal shifts, left and right shifts, plus actually moves it left. So it moved it left 3 units. So pretty sure by common sense most of you will know what the next one's going to do, but let's just plug it in and see. Y equals parenthesis x plus 7, and then squared on the outside, and when you graph it, you see that the new parabola is over to the left by 7 units. Yes, they always move from the origin. Okay, so it moved it left 7 units this time. And remember, those moves, those shifts, are always starting from the origin. Correct. Okay, so now let's look at the rule. The graph of y equals x plus a in parentheses squared will cause the parent graph to move left a units, right? Okay, now let's try the next one. Go ahead and type in y1 should already be there. Type in y2. Okay, y1 is just x squared, your parent function that's at 0, 0. And then y2 is x minus 3 squared. But it actually moves it to the right 3. So what do you think is going to happen when you type in x minus 7 all squared? It's going to move right 7 units. And that's from the origin. I mean, think about it. When you look at that graph, isn't that 3 units away from the origin to the right? And then if you were to put in the other one, x minus 7 squared, isn't the vertex of this parabola 7 units right of the origin? Okay, everybody knows what I mean when I say vertex of the parabola, right? The vertex is where the parabola changes directions. Okay? Alright, so for the rule, the graph of y equals x minus a squared will cause the parent graph to move right a units. Okay, so let me recap again. Here we go. If you just have x squared, and then all of a sudden somebody's put a plus a number, that moves it up by that number, correct? If they decide to put minus a number, it'll move the whole thing down by that number. If they have it in parentheses and it's plus, that's left that many units. If they have it in parentheses and it's a minus, it's right that many units. Okay, so for up and down is common sense. Plus is up, minus is down. But for left and right, it'll always be in parentheses, and it's not really common sense. Plus actually moves it left, minus actually moves it right. Okay, now let's look what happens when you throw a negative out in front of the x squared. So first just graph y1 and y2. Okay, y1 is just x squared, your parent graph, and y2, the parent graph has been changed by putting a negative in front, multiplying it by a negative. And what does that do to the graph? It flips it or reflects it, correct? So it flips it, or you could call reflects, over the x-axis. Because didn't it flip it like over the x-axis? Okay, so now type in negative 3x squared and see what happens. Right. Once again, that negative in front flips it upside down, but the 3 does make it skinnier this time. Okay, and we're about to move into that in the next box about making it skinnier or fatter. Okay, so for this one, the conjecture is that multiplying the parent graph by a negative, putting a negative out in front, causes the parent graph to do what? Flip or reflect, however you want to say it. Okay, so now, type in for this box just the first two. Y equals x squared, y equals 3x squared. obviously the second one has a 3 out in front. What does the first one have out in front? A 1. It's 1x squared basically. So let's see what putting a 3 does to it. What did the 3 do to it? It made it skinnier, okay? Which is known as a vertical stretch. So it makes it skinnier, and that's known as a vertical stretch. Did I spell that right? Yeah, that's the... It's right. It just looked weird. Yeah, here it is right here. Okay, so now look. Let's see what happens if you throw a 7 in front, which is an even bigger number. Oops. Okay, so y equals, this time I'm going to go bigger than 3. I'm going to go 7x squared. What happens? Even skinnier, right? So the larger your number gets over 1, the skinnier it gets. It stretches. Okay, so multiplying the parent graph by a number whose absolute value is greater than 1 causes the parent graph to stretch or get skinnier, right? Okay, go and flip to the next page. Okay, now let's type in the first 2 from this box. X squared will already be there. So just type in 1/2 x squared. Now let me say this. Pay attention. You do not have to go to alpha y equals n over d to type in this 1/2. You can just type in 1 divided by 2. And then x squared. Now remember, with our parent function, what's the number out in front of this x squared? 1. So now we're getting smaller out in front, correct? Let's see what happens when you put a smaller number than 1 out in front. It gets wider, right, or fatter. Okay? So it gets fatter, or you could say wider, however you want to say, and that's known as a vertical shrink. Okay, so look, 1/4. Is 1/4 bigger or smaller than 1/2? Smaller. So let's see what happens if you go even smaller out in front of the x squared. 1 divided by 4x squared. Even fatter, right? So the smaller you get below 1, the fatter your parabola will get. So multiplying the parent graph by a number whose absolute value is between 0 and 1, and aren't numbers like 1/4 and 1/2 between 0 and 1, causes the parent graph to shrink, which will cause it to get fatter. Now, I'm about to show you something to help you remember that skinnier is a vertical stretch and fatter is a vertical shrink. Okay, let's continue. Based on your conjectures above, sketch the graphs without using a calculator this time. Okay, well let's look at this. We have x plus 3 in parentheses. In parentheses is what kind of shift? The left and right, correct? Anytime it's in parentheses, doesn't that mean it's a horizontal shift? It'll move it left or right? What does plus 3 move it? Left 3. Remember, horizontal shifts are always opposite of what you would think. Plus actually moves it left. Numbers outside the parentheses move it up or down. In this case, it'll be down 4. So that means our vertex of this parabola is going to be left 3 and then down 4. Now, is my U-shaped graph going to open up or open down? What would make it open down? There's no negative out front. It'll open up because it's positive out front, right? Now, to get an exact, like to be able to graph it perfectly and know exactly where it goes on each side, wouldn't we have to create a table of values like we did on the first one? But right now, we're just going to do a rough sketch. We just want to know where the vertex is and whether it opens up or down, okay? Okay, so now let's look at this one. What are some things you notice? How is it different than just your y equals x squared? What's added to it? What's different? We have a negative, and what does that do to the parabola? It'll flip it, correct? And then what does this plus 5 do to it? Up 5. Remember, outside numbers that aren't in parentheses move up or down. Plus is up, minus is down. So we're going to first start by moving it up 5. 1, 2, 3, 4, 5. And then we're going to flip it upside down because it was a negative out front. Now remember, I'm probably not perfect on where exactly, these lines should go. To get it perfect, you'd have to create an XY table, put in numbers like 1, 2, 3, 4, plug them in, and get your Y values and plot them. But right now the goal is just to figure out where it starts and whether it opens up or down. Okay, now we're going to go back and we're going to graph these on the calculator and see if we were correct. Okay, so on your calculator, y equals, I'm going to clear out everything from before, and I'm going to type in parenthesis x plus 3, close parenthesis, square it, and then minus 4. Is everybody comfortable now typing that in? Now let's graph it and see if it looks like our graph. Pretty similar, right? I mean, the y-intercept looks to be up at 4, and mine didn't quite cross up at 4, but remember, to get it exactly right, you would have to create a table of values like we did on the very first question today. Okay, so now let's check our second one. Y equals negative x squared plus 5. Okay, does that look like ours? Pretty much. I mean, I might have gone a little too wide on this side, but, when you're sketching it, you're not perfect unless you have points to go through. And the only way to get points is to create a table of values, which we're not going to do right now for these. Okay, based on your conjectures, write the equations for the following transformations to y equals x squared. So remember, all of them start out like this. Okay, all quadratic functions start out y equals x squared. Say you wanted to move your parabola 6 units up, how would you need to show that in the equation? X squared plus 6. That plus 6 would move it up 6, right? What if you wanted to... Say that we wanted to take our parabola and move it 2 units right. How do you express that in the equation? Y equals...
X minus 2.
Squared. Very good. To move it right or left has to be in parentheses. Right is represented with a minus and then 2 for 2 units. And then to make it a parabola, you have to square it. Otherwise, if you didn't square this, wouldn't that be in y equals mx plus b form, which would be a line? Okay, what if we want to just stretch it vertically by a factor of 3? No, that'd be vertical stretch.
Okay.
So how do you stretch it vertically by a factor of 3? Right, you just throw a 3 out in front. Whatever number you want to stretch or shrink it by, you put it in the front. If it's a stretch, it's over 1. If it's a shrink, it's a number below 1. Okay, what if we want to reflect it over the x, move it 2 units left, and down 5 units?
Y equals parentheses negative x plus 2 parentheses
Okay, minus 5. Everything was right except for the fact that to reflect it, the negative needs to go outside, not inside with the x. So negative on the outside, and then inside x plus 2 to move it 2 left, and then outside minus 5 to move it down 5. Okay, turn to the next page. This is your homework. So all you're going to do is write like this one, x squared plus 4. Doesn't that just move it up 4? You're going to write what happened with each one. I will give you your pink sheet tomorrow before I come around and check it, but your homework is page 4. You'll get a reminder at 6 o'clock.